Hi, I'm Nathan Johnson, and in this video I'm going to provide an overview of the iecTeso Workbench. iecTeso is the development environment for OEM programmable controllers. It supports all of the IEC 61131-3 languages, which include ladder diagram, function block diagram, structured text, instruction list, and SFC. IEC 61131 is the international standard for programmable controllers. Some of the key terms we need to familiarise ourselves with are configuration, which is a hardware platform that contains one or several resources. For example, this could be an OEM PC1 or PC3 controller. Then you have a resource, which is a PLC loop that will execute one or more programs or program organizational units or POUs. Each POU is a set of instructions that are executed in a specific language, and a POU could be a program, a function, or a function block. iecTeso supports having multiple configurations, each containing one or more resources that can be programmed and set up in a distributed network to communicate with each other, all from within the one project. Variables can be shared between resources and configurations through bindings. So you can bind variables between resources, and then you can bind variables between configurations through network bindings. iecTeso can be launched from the Start menu under the OEM iecTeso program group and by clicking iecTeso 5.2. When you start or open a project, it starts up in the link architecture view. On the left hand side we have a project tree which allows us easy access to various parts of the project. You can also use the toolbar to navigate between the key features. I'm going to start off by opening up the hardware architecture view. The hardware architecture view shows all configurations and their connections to a network. In the example project I have here, there is just one configuration. In this case it's a PC3024, which contains two resources. This project has been set up with a TCP network, and the PC3024 is connected to that network with a designated IP address. Over on the link architecture view, there are two resources, and links between the resources are shown in the form of bindings. Each resource has an I/O wiring screen, which is where you define all physical I/O connections to the resource. In this case, in this particular example, there are a series of PC3 I/O modules configured. The PC3024 is made up of two IO 3530 modules and two IO 3400 modules. These can be expanded out to give the breakdown of their I/O. In this case, the IO 3530 contains 6 analog inputs which have I/O mapped to them, and 2 analog outputs which have also had some variables mapped to them. Variables are mapped on the I/O wiring screen using a simple drag and drop user interface. In this case here, I just disconnected a variable and then dragged and dropped it back in. Each resource then has a dictionary, which is where all the variables are defined. These can be grouped into individual variable groups or access through the dictionary on the toolbar. In this project, there are a series of variable groups set up, or we can simply access all variables in the resource. Projects will often consist of a large number of variables, so a simple way of determining where they are used is via the browser utility. Through this, you can then look at any particular variable and you can find out where it's referenced in the project and whether it's being written or read from. You can also double click on this to access the usage directly in the code editor. The next item in the resource list is programs. Multiple programs can be written in a resource using any of the IEC programming languages. You can also create functions and function blocks, and again, these can be created using the various IEC programming languages. The programs as functions and function blocks are all written in a multi-language editor. If I open up the inputs program here, this is a ladder diagram program. Similarly, I'll open up the first run program here. This one's been written in structured text, which opens the editor in structured text view. iecTeso also includes a graphical debugger. If we connect to the controller via the debug menu, debug target, we get a live view of all the variables in the system in the dictionary. We can also open up the code editors to get a graphical representation of the code executing. We can access the I/O wiring screen to view the I/O points live. We can also create spy lists to view a custom set of variables. We simply select whatever variables we want from the dictionary. This could be across multiple resources and it will show their states. I find this feature really useful when developing new code and wanting to create a very specific view of particular variables. While debugging, you can also lock and force any variable in the system. Simply go to the dictionary, double click on a particular variable, lock it, then double click on it, and you can define or set another value which will become the logical value which the PLC code will execute on, while the physical value is shown separately. This is a particularly useful feature when testing, as this will quite often be done on a bench when you don't have a connection to a physical system. It allows you to then set states you expect to see in the field on the actual machine you are controlling. iecTeso also has an inbuilt simulator. If we disconnect from the actual target, we can then launch the simulator from the debug menu instead. This then provides us with a I/O simulation panel where we can set the states of the inputs. And also allows you to test code. It should be noted, however, that simulation code does not exist for all C function and function blocks. So I would usually debug code on a real controller. iecTeso also allows password protection at many levels. You can password protect an entire project. You can password protect a configuration. You can password protect at a resource level. Or you could password protect individual POUs. iecTeso also has a import and export utility. It allows you to import PLC definitions, exchange files, which are basically allowing you to import projects or POUs. And you can also import variables. This is quite useful when you're starting out a project, and rather than entering variables one by one into the dictionary, you could create a list of them in Microsoft Excel and then import them through this feature. You can then export projects or part of, and you can also export variables. iecTeso also supports libraries for sharing reusable code. This is done through the form of dependencies. Dependencies can also be created on external projects. However, generally you would create all the code within a single project. Finally, if your project contains multiple resources, variables are shared between resources in form of bindings. These are shown here, the lines between the two resources. In this case, there's just an arrow in one direction. Double clicking on this link will show the bindings. In this case, we are sharing a variable from resource R30697 to resource 2. Hopefully that provides you with an overview of iecTeso. We will look at features in more details in separate videos.